Okay, yesterday we talked about classifying functions, and we looked at linear, quadratic, exponential, and absolute value. All right, let's kind of review a little bit. Linear, we classify that it's the exponents is 1. On quadratic, the exponent is, the highest exponent is 2. On exponential, the exponent is x. And absolute value, really you're just looking for the absolute value bars. If it doesn't have that, it's not absolute value. Okay? On the shape of the graph, linear is a straight line. Quadratic is a horseshoe. It's called the correct name for the shape is called parabola. Okay, so if you see the name parabola, that means the shape of a quadratic. That's what it forms. It could be going down, it can be going up, it can be going sideways. Okay, but mostly we'll be dealing with up and down. It's going in one direction up, and then it turns around and comes back the other way. Same thing here. It was going down, and then it's going back up. So it makes a turn and goes the opposite direction. All right, exponential is a curve up, or it could be a curve down. But it's a curve as well, just like quadratic, but there's no turnaround. Okay, no turnaround. It's only going in one direction. Absolute value is a curve, but it's technically two straight lines. Okay, that form a V. It comes to a point, which is your vertex. Okay. All right. One thing about linear I want to go over is denominator. You can't have an x in a denominator. Other than that, if it's the highest exponent's 1, it's linear. Okay. All right. So today we're going to look at identifying. Here we were classifying, so we're going to identify the functions when we're looking at the table. That's going to be our primary thing. We'll do graphs and equations, but our primary focus is going to be identifying a function by its table. Okay? All right, so let's go to the, and this is the first page on your notes. Example of an equation. That would be, oops, I gotta do y equals 3x plus 2. It can be slope-intercept form. You could do standard form. You could do point-slope form. All right, all of those are linear. None of them have an exponent greater than 1, and none of them have an x in a denominator. So it's linear, okay? So I know it's going to be in the equation's linear when the exponent, the highest exponent is 1. Okay, examples of exponential would be 2 to the x, or y equals 3 times 4 to the x minus 5. Y equals 1/2 to the x power plus 2. All of these have in common that they have that exponent of x. All right, so when we see a variable as the exponent, then it's going to be exponential. Quadratics, we know that they're going to have x squared. It's the highest exponent. highest exponent is square. So like y equals 2x squared plus 2x plus 4. That's standard form quadratic. You could also see it in vertex form, which would be like 2x minus 3 squared plus 6.
Nurse Sheila.
All right, those are all going to be quadratic functions. All right, absolute value, we know it's the absolute value bar. So we're going to focus on these three. These are the three that have a lot going on. Absolute values, simple. Has absolute value bars, is shaped like a V. All right, tables. All right, so this is where we want to look at. Let's say that I got y equals 3x minus 2. All right, I have my x and my y. If I have 0, 1, 2, 3, 4, okay, and my y would be, if x is 0, I plug in 0 for that, it's going to be, my y is going to be minus 2. If I replace x with 1, 3 minus 2 is 1. If I replace x with 2, 6 minus 2 is 4. If I replace x with 3, 9 minus 2 is 7. And if I replace x with 4, 12 minus 2 is 10. Okay? So I've got my table. I could have gone to my calculator, put in this into y equals, and looked at my table to fill it out instead of doing all the math. But what we want to look at now is, just suppose I didn't have the equation. All I had was this table, and I said, what type of function is that? All right, what you're going to look at is the change, the rate of change. Over here, we're going up 1 every time, right? So from negative 2 to 1, what happened? It went up 3. Negative 2 plus 3 is 1, right? 1 to 4, what'd they do? They added 3. 1 plus 3 is 4. 4 to 7 went up 3. 4 plus 3 is 7. And 7 plus 3 is 10. All right, so they have a constant rate of change is 3 over 1, or 3. This is your first difference. Okay, they're looking at the difference between this number and this number. It's positive 3. Okay, they're looking how did it change each time? It went up 3. That's your first difference. So if the first difference is constant, then it's always going to be linear. Okay? If your first difference is constant, then it's linear. All right? Your pattern for your y values is plus or minus. Okay, it's going up 3. It could be going down 3 each time, but it's constant. It's the same thing every time. All right, looking at exponential, let's say that I've got y equals 2 to the x power. So if I gave you the table of x is 0, then y is 1, and I gave you the domains, 0, 1, 2, 3, 4. And you put this in your calculator and you looked at your table and it said when x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8. And when x is 4, y is 16. Okay? So now, again, suppose I didn't give you the equation. I just gave you the table. And I said, how can you identify what type of function this is? All right, so you're going to look, how did my x change? Well, it went up 1 every time, right? So your y is going to be your telling story, okay? So this went up 1, this went up 2, this went up 4, this went up 8. I see a pattern, but you know that it's doubling every time, right? 1, 2, 4, 8, it's doubling. So it means that what they're doing is, instead of adding or subtracting, they're multiplying by 2 each time. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so if you ever see your numbers are not the same, it's not constant, but it has that pattern of like it's doubling or tripling, or it could be times 1/2. It could be splitting in 2 each time. All right, then it's gonna have a ratio instead of adding or subtracting. All right, it means that they're multiplying. Okay, the way you can find it, I always look at my bottom numbers. 8 times what is 16? So you could take 16 and divide it by the number in front of it, and that gives you 2. So it means you're multiplying by 2. If I said 2 divided by 1, 2 divided by the number behind it, and that gives you 2. 4 divided by the number behind it, 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Okay, so they're multiplying by 2. All right, so I know a table is an exponential function when it's the y values are multiplying. Okay, you have a ratio. Okay. All right, and quadratic. Quadratic's the one that's a little bit different. Let's say that I gave you the equation y equals 2 times x minus 3 squared plus 6. All right, you have your square, so we know that that's going to be a quadratic. My table, I gave you a domain of 1, 2, 3, 4, 5. And so I put this in my calculator, looked at my table. When x is 1, y is 14, and x is 2, y is 8, x is 3, y is 6, 8, and 14. Okay. All right, so we're not, when I go from 14 to 8, I'm subtracting 6. 8 to 6, I'm subtracting 2. 6 to 8, I'm adding 2. 8 to 14, I'm adding 6. So, see how we got 6, 2, 2, 6? It's kind of like it makes a turn right here. It goes from subtracting to adding. It was going down, now it's going up. Okay? So kind of like a quadratic, it goes in one direction, it makes a turn and goes the opposite direction. All right, so now we got one more thing just to verify this. Look at going from -6 to -2. What did you have to do to -6 to make it -2? If I added 4, -6 plus 4 is -2. All right, if I say -2 plus 4, that'll give me 2. If I say 2 plus 4, that'll give me 6, right? And if I had 6 and I added 4 more to it, that'd give me 10. So I could say 14 plus 10 So the next number would be 24. So if you look at your table, I guarantee you'll see if x is 6, y is 24. So we can use these patterns to find the next number coming up or what it was before, which we will do that as well. All right, so over here on linear, this first difference is constant, right? Well, on quadratic, the first difference, this is your first difference, right? Well, it's nowhere near constant. But if I look at my second difference, it's constant. It's going up by 4 every time on my second difference, okay? So I know it's a quadratic when the second difference is constant, okay? And my y values, they go up and down, or vice versa, down and up. All right, they make a turn. Okay. All right. Let's see. For my graphs, we know it's linear if you've got a straight line, right? A straight line would be preferable. It's going up, it's positive, going down, it's negative, okay? So it's a straight line. Conclusion, straight line. It's going to be a long video, y'all. All right, graphs, exponential. It does a curve, right? It can be going up or down. A curve with no turnaround. It's one direction. I remember a long time ago, freshman girls coming here with One Direction on their little backpacks. I thought, oh, my word. That was completely off subject. Graphs, quadratic. It's a parabola, so it's shaped like a horseshoe. Okay? It's, it either increases and then decreases, or it decreases and then increases. All right? It turns around. It's a curve that turns around. All right. Okay, let's go to the next page. Okay. Hitting the wrong button. All right, I'm not going to do every one of these. This is, what type of function? It's linear, right? We know that because the exponent is 1. This one is quadratic. We know at y, the exponent is 2. This one is exponential. We know at y because the exponent is x, or a variable. This one is quadratic. Exponent's 2. This one, exponential. This one, linear. Linear. Exponential. And quadratic. All right, let's get to tables. This is where the, all right, we don't have an equation, but I need to know what type of function it is. So I look over here at my x's, and they're either going to be going up 1 or down 1. It's going to be constant over here. So we're adding 1 every time over here. Okay, that's usually the same on all of them. All right, so 4 to 6, we added 2, added 2, added 2, added 2. All right, this one's pretty easy. First difference is constant. First difference is constant, so that means it's going to be linear. Okay, It's a straight line. Our slope is 2 over 1, or 2. It's going up 2 for every 1 x, okay? So, on number 2, we're going up by 1 over here. Here we went down 3, down 1, up 1, up 3. All right, we already got our little pattern here. -3, -1, +1, +3. Okay? If you look here, we're adding 2, adding 2, adding 2. 1 plus 2 is 3. -3 plus 2 is -1. So my second difference is constant. Our second difference is constant, so it's quadratic. Now, what if I asked, what is the value going to be when x is 9? If x is 9, what would my y be? Well, if we're adding 2, 3 plus 2 is 5, right? And 8 plus 5 is 13. What if I said, what is it when it's 3? Well, if we were adding 2 going forward, that would mean that going backwards, we're subtracting 2. So what minus 2 is -3? Oh, excuse me, plus 2. What plus 2 is -3? What? -5 plus 2 is -3. All right, so from 8 minus 5, going backwards, so what minus 5 is 8? 13. 13 minus 5 is 8. What do we notice about these numbers? We have a turnaround right here. Went 4, 5, 8, 13. 4, 5, 8, 13. Right? Okay. And you know, it takes, the quadratics are the ones you have to really play with to get your prediction of previous or forward. All right, so we're adding 1 here, plus 4. Ooh, plus 20. Okay, what are we doing here? When you say we're times 5, 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. So all of these is, we're multiplying, so this one's going to be, since we're multiplying, is exponential. That's why it goes up. The numbers go up so much quickly. It's because we're multiplying instead of adding or subtracting. Okay. All right. Here. 4, 8, 16, 32, 64. These numbers are kind of going up quick, aren't they? All right, so if you take 8 and divide it by the number behind it, 4, you get 2. So if you say 4 times 2 is 8. 8 times 2, 16. 16 times 2 is 32. So this one, again, is exponential because we're multiplying. See, after you kind of get used to looking at the numbers, you can kind of tell exponential right off. All right, here we're plus 1. And -5 to -1. What do you have to do? -5 plus 4 will give you -1, right? -1 plus 4 is 3. 3 plus 4 is 7. 7 plus 4 is 11. So We're constant in our first difference, so it's linear. Okay. All right, let's look at equals. All right, this one, we got some big numbers going to a small number, but we're going down. All right, so it looks like it's exponential because you got big numbers and little numbers in a short period of 5 turns, 5 times you're doing. But we're not going up, so it can't be like times 5 times 10. So we need to be going backwards. So let's take 64, and we're going to divide it by the number behind it, 128. Okay, you have to put 64 in your calculator first. 64 divided by 128 is 0.5. All right, so what it's doing, it's multiplying by 1/2. All right, it's just halving everything. So if you multiply by 0.5, okay, so it's multiplying. It's getting smaller, but it's still multiplying, so it's exponential. Over here, -3, -3, -3, -11 minus 3 is -14. So this is constant, first difference. Constant, first difference. So it's linear. Okay. Look at this one. All my y's are 2. That ought to be able to, eventually you'll be able to look at that and say, oh, well, I know right off what that is. Some of you might know. Okay, so all my y's are 2. So 2 to 2, what did it do? It went up 0. It went up 0. It went up 0. It went up 0. Here we were going down 1 each time, right? So my slope is 0 over -1, which is 0. So I got a 0 slope, which is basically a flat line. So when your y's are the same, you have a horizontal line, a horizontal linear function. Okay. All right. The rest of these, you should be able to identify these graphs by what they look like. I don't think there's any problems on those. Linear, exponential, exponential, quadratic, linear, and quadratic. Okay. All right. You have your homework is basically the same thing we were doing on our notes, just different tables and different problems. So go ahead and do that. Thank y'all for hanging in there. All right, bye.